Well, hello there. Today we're going to be talking about how to write equations of lines. And I think the big thing is that if you are trying to write the equation of, say, a vertical or horizontal line, you just need x equals or y equals, and whichever one is true. And so I think that's the big thing that I would start with to say, hey, if you see a line that has just like, I don't know, every single point looks like this right here. You're like, okay, well, there you go. Well, then look at the points that are on that line. And the equation has to be made true by every single point on the line. Well, this, if you list out the points on this line, this is going to be 3 and then 1 and like 3, 0 and then 3, -1 and all the points on this line. Oh, you'll notice, hey, guess what? The x coordinate of that line, of every point on that line is always 3. So every vertical line is just x equals a certain number. So a vertical line, remember the vertical lines have an undefined slope that's like the infinite or so undefined. It's as big as it can get. And so x is equal to 3. And so vertical lines have an undefined slope, and their equations are x equals whatever number is always true about the x coordinate of their points. And then on the other side, if you've got a horizontal line, you'll notice that for every point on a horizontal line, say this is up here at 4, every point will be like a number comma 4. So like -1 and then 4. That would be this point right here. 0 comma 4. And so every horizontal line is always y is equal to a specific value. And so vertical and horizontal lines, again, that has a slope of 0 and it is y equals its HOI. And so slanted lines have both x and y in their equations. And so the way that you write them would be kind of, there's a couple options. It depends what you know. And so you have grown up looking at a graph and being like, oh, if I can see the y-intercept, I know that's b. If I can count the slope, then I know that's the m. And you're like, oh, cool, this is going to be y is equals to, say, 2x plus 2. Okay, well, I guess in this case, let's change that to make that a 3. Okay, so if the y-intercept, say, at 3, the y-intercept goes here because that's how much above or below the y value. The y-intercept value is going to be above the origin, and the slope is going to be how steep the graph is going to be. So this is y is equal to 2x plus 3. And so if you've got a graph and you can see the y-intercept and the slope, you can write the equation straight into slope-intercept form. And so that's really a classic thing to do, if you can see those two values on the graph, or if they give you those values. So again, m represents the slope and b represents the y-intercept. And so m, like a mountain, is the slope, and b is going to be the y-intercept. And so on these first two equations, there are problems. They're going to say, hey, write the equation of a line, and I'm going to give you the slope, and I'm going to give you a point on the line. Now, if the point they give you is the y-intercept, well, then you know b. But the problem is, on this question here, they don't give you the point that you're probably looking for. You're probably looking for the y-intercept. And so if you don't quite know both m and b, this formula over here is really helpful, okay? The point slope formula. So the name of this is going to be named upon what you know. A point on the line, because there's infinitely many points on any line, and the slope. And so if you know two things, the slope and the y-intercept, a slope and a point, you can write the equation of a line. And I would use this formula right here, where m is the slope, and the point, or one of the points on the line, goes in for x1 and y1. So if you've got a point on the line, any of the points on the line, you can plug in the x coordinate of that point as x1 and the y coordinate of that point as y1. So it's going to go, the y coordinate goes there, the x coordinate goes here, and you will leave an x and y in your formula because that's kind of how you want to write an equation. So you plug in these three values, the m, the x1, and the y1, into your equation. Your x and y will stay as x and y, and you can have the equation. So let's try that with a couple questions. So if you can, from the graph, go straight to y equals mx plus b, awesome. But sometimes you need to use point slope to help you get to another form of the equation of line. So let's do this. Sorry, pardon me. So here we go. So this says m is 2, and here's a point. Okay, if you knew m and b, you would plug those in, correct? However, you don't know m and b, but you know a point. So you're going to call this x1 and y1. So let's do this. Let's do y minus the y coordinate of the point, which is 11, equals m, which is 2, x minus the x coordinate of that point, which is 3. So we plugged in the point and the slope of 2, the point, which is 311, and every line has so many points on it, infinitely many points on it. And so as long as you know one of them, and you can either find the slope or you know the slope, you can write the equation. Now the question is, how do they want their final answer? Okay, this final answer, they say, put it into point slope form, and that's your final answer. So your final form should match what they want. And so point slope formula will look like this: y minus a y coordinate equals m, and then x minus an x coordinate. So this will be your final answer to this problem. The next question will be similar. Again, if you can find the slope or you know the slope and you know one of the points on the line, then you can write the equation. So it's going to be y, this is x1 and this is y1. So you're going to do y minus the y coordinate of the point that you know, and that's negative 12, equals m, which is negative 2.4, and then x minus the x coordinate of that point, and it's a negative 14. If you ever see minus a negative, you should change it to a plus, a positive. And then that should be our answer. So this is a little blobby looking, and so I should rewrite it so you guys can see. It should be y plus 12 equals negative 2.4, and then it should be x plus 14. Okay, so that's what that equation will look like in point slope form. So once you write the equation, make sure, what do they want your final answer to be in? Okay, and so let's look at the next one. It says, okay, they said write your answer in slope intercept form. Okay, point slope form is this one on the right where you can see the point and the slope easily. Slope intercept form is y equals mx plus b. So the thing is, they want us to put it into y equals mx plus b, but sometimes you can't go directly there. If you want to fly to China, you probably can't fly straight from your home to China. You've got to do one more step, like get to the airport, and then probably can fly there. Well, same with this. If they want you to get it into slope intercept form, sometimes you can go directly from point A to point B, but sometimes you actually need to do an intermediate step, okay? And so these two first talk about go to slope intercept form, which is y equals mx plus b right here. And we do know in this case m and b. M is the slope and b is the y-intercept. And so we're going to plug this in there. So let's do y is equal to the coefficient of x, the m value, is going to be negative 5, and then you put an x, and then minus 2. So here is the slope-intercept form of this line. Okay, so they gave us the slope, and they gave us the y-intercept. So, hey, that was pretty easy. We plugged it in for the m and the b. Now the next one, they gave us a point on the line and the slope. And now if you look at this, you can tell that the point on the line is actually the y-intercept, 0, 4, over nothing but up 4. That's the y-intercept. So you might notice, hey, I can go straight to the y equals mx plus b, but you may be a little bit confused. And let's go kind of this other direction and notice what you will get. So if you know a point on the line and you know the slope, you may say, I need to write the equation. I know I want to get it into y equals mx plus b form. That's a slope-intercept form. But I don't necessarily know both parts. And so to get there, like if you're going to China, you may need to start by taking one step first and then getting to that form. And so let's call this point x1 and y1. So you're going to do y minus the y coordinate of that point, which is 4, equals m, which is negative 3/4, and then x minus the x coordinate of that very same point, which is 0. Now this is point slope formula, and they said don't leave it there. They said put your final answer in slope intercept form. So even if they give you a point on the line and the slope, or you find the slope, you can eventually get it into slope intercept form if you do the appropriate math. And so to get y equals mx plus b, we have to solve this equation for y. So let's distribute right here. And so I'll go up here, and you're going to go y is equal to, actually I lied. Let me erase this real quick. Stop lying, woman. Here we go. So y minus 4 equals, and if I distribute the negative 3/4 to x, I get negative 3/4 x. And if I take negative 3/4 times 0, I get 0. Okay. And to get y equals mx plus b, you're going to have to plus the 4 to both sides. And so you will write for your final answer, y is equal to negative 3/4 x and then plus 4. And from this format, you can tell, hey, the slope of this line is 3/4 and the negative 3/4, and the y-intercept is going to be at positive 4. And you can kind of see that with the point they gave you. The y-intercept is at 0, 4, really is at 4, okay, on the y-axis. So you can either, if you go straight to the slope-intercept form from this format, you can see it, or if you take that other step to say, let's put it into point-slope format, and then manipulate my equation into slope-intercept form. So that's a good choice. The next one says, hey, do you see these two points? Can you write the equation of this line? You're like, I don't know if I can write the equation of a line and given this. Okay, so it tells the directions on the right. Step 1, find the slope. You always need the slope when you're going to write the equation of a line. Then the next thing is choose one of the 2 points or one of the infinitely many points of the line and plug that into the point slope formula so you can write the equation. And if you need to, manipulate your equation to get into y equals mx plus b. And so I feel like this next step is not too bad. We've got to find the slope. So you're going to do y2 minus y1 over x2 minus x1. So you're going to do 9 and then negative 6 and put a subtraction sign between it for the y's. You're going to do 8 and a negative 12, and you're going to put a subtraction sign between the two x's. You're going to do the math of the numerator and the denominator to calculate the slope. So if you do 9 minus negative 6, you're going to get 9 plus 6, which is 15, over 8 minus negative 12, which is going to be 20. Reduce that by dividing top and bottom by 5, and you're going to get 3/5. So our slope between those 2 points is 3/5, or 3/4. I lied. Sorry. Let's fix that. Okay, so 3/4. Divide top and bottom by 5, and you would indeed get 3/4. So once we know the slope, we need the y-intercept. And the thing is, there's a couple ways to find it. If you look at your delta math directions inside there, they kind of use a different method, which is fine. And some of you guys might have learned doing that. The way I prefer to do it is to say, well, choose a point, either of the ordered pairs, and write the slope combined with that one of the points, and you can write the equation. So I like the point 8,9, and I'm going to use the slope of this, and it's 3/4, and I'm going to put those together into the point slope formula. And so you could use the other point as well. Your intermediate steps might look a little different, but you're going to still get to the same slope-intercept form. So this is x1 and y1. And I don't know why I'm using a highlighter, but all right, so let's do y subtract 9 equals m, which is 3/4, and then x subtract 8. And that is an equation of a line. If it just says write an equation, you can stop there. If it says write an equation in point slope formula, that is valid, okay? But if it says, hey, I want you to get this into slope-intercept form, slope-intercept form is where you can see the slope and you can see the y-intercept, and it really is y equals mx plus b. And so you have to solve your equation in terms of y equals. So you have to distribute this, and if you need to use the fraction key in your calculator, you're welcome to. This is 3/4 x. And if you want to multiply, I'll go up here, 3/4 times negative 8 over 1. You can multiply the top and multiply the bottom and then divide it. You get negative 24 divided by 4, which is going to be negative 4 over 4, which is negative 6. So when you distribute the 4 times negative 8, again, use your calculator if you want to. You get y minus 9. To get y equals mx plus b, we need to solve for y. So we're going to plus 9 to both sides. And you get y is equal to 3/4 x and then plus 3. So our equation of the line that is formed between the 2 points, negative 12, negative 6, and 8, 9, is this equation right here, y equals 3/4 x minus 3. And there are multiple ways to come up with this equation, but that is the equation that contains those 2 points as well as infinitely many other points in line with them. Okay, so there's a lot of points on that line. And so, we can do the same thing with the problem below it. We're like, hey, let's write the equation between those 2 points. 2 points determine a line, and if they say write the equation, well, step 1 is to find the slope. Step 2 is to write an equation about it. And so a really good method is to calculate the slope using y2 minus y1 over x2 minus x1. So negative 11 and 4, and put a subtraction sign for the y's. Negative 4 and 2, put a subtraction sign between those for the x's. You got to be consistent with your order, and you get negative 15 over negative 6. Divide top and bottom by 3, and negative over negative is positive. So divide by 3, and you get 5 halves, and it's positive. So that's your slope. So if you know the slope, or you can find the slope, okay, And we just found it. 5/2 is your slope. You're going to take a point, and I'm going to take the nicer looking point. That's 2, 4. And say I'm going to call the x part x1, and the y part y1. And you do y minus the y coordinate of the point you're choosing. One of the points on the line equals the slope, n. And then x subtract the x coordinate of that point. If it just said write the equation of the line, we could stop here. But it says write it in slope-intercept form. Okay, so we are going to distribute this out. 5/2 times x is 5/2 x, and then 5/2 times -2. Okay, I'll go way over here. We've got 5/2 times -2, or -2/1. You get -10/2. -10 divided by 2 is going to be -5. -10/2. Again, you can use the fraction key in your calculator, and that's going to be -5. And then y minus 4 equals that. So add 4 to both sides, and you get y is equal to 5/2 x and then -1. So the equation that calculates those 2 points is going to be right there, 5/2 x -1. You need the slope, and one of the ways to write the equation is to use the point slope formula, which includes finding the slope and plugging in one of the points on the line. Now the next two are going to turn out weird. Okay, if you notice that, when you're calculating the slope, you get 0 or undefined, you're going to get either x equals or y equals. And you can just look at your original points and kind of tell, oh, are x is the same or y is the same? And that's going to be your answer. And so, if you notice, hey, guess what? I'm looking at these points, both of the x's are -3. The equation is going to be x equals -3. That's the answer. And you can go straight to it. I could care less. Okay. And if you are looking at your 2 points, you're like, ooh, both the y's are -4. Well, then guess what? The equation is going to be y equals -4. I mean, that's just always going to be the case. That's the answer. And so I wanted you guys to realize, if your slope is 0 or undefined, yes, it's going to be x equals or y equals. It just is. And so, notice it whenever you need to, but it's going to be the truth no matter what. So if you do 4 and -2 and you put a subtraction sign, you're going to get 6 on the numerator. And if you do -3 and -3 on the bottom, put a subtraction sign between the two x coordinates, you're going to get 6 divided by 0, which is undefined. That's a vertical line. And so guess what? You're going to be like, hey, how do I do that? Well, it's going to be Vox. Vertical lines have an undefined slope and they're x equals. If you look at the 2 points they gave you, notice both the x's are both, oops, I just erased that. All right, just colored over it instead of highlighting. Both the x's are both -3. Well, then that's going to be your equation. X is always -3. Same with the one below. If you find the slope between those 2 points, -4 and -4, and put a subtraction between them. 3 and a -1 and put a subtraction between them. Hey, on the numerator, you're going to get 0. On the denominator, you're going to get 4. 0 out of 4 is 0. That's a horizontal line. And horizontal lines have 0 for their slopes, and they're going to be y equals its y. And so however you best want to come up with it, both y coordinates are -4, that's the equation going to be. And so it's pretty cute to do that kind of a thing. Okay, so the next part is, in geometry, in algebra, they always try to give you like hints and say, can you come up with these things? And so, they're like, hey, I'm thinking point on the line. You're like, great. I'm probably going to use point slope formula. Yes, of course you are. And they're like, hey, I want you to write an equation through that point. Okay, like, okay, great. Well, that means this is x1 and y1. Great. And I want you to do perpendicular to this line over here. Okay, so the only thing we really care about is what we know about perpendicular lines. Perpendicular lines don't have the same slope as each other. They have opposite reciprocal slopes from each other. So if this slope right here, this line has a slope of 1/2, what would be this? Let's think about our clues. What would be the slope of a line that is perpendicular to a slope of 1/2? Well, it's going to be the opposite sign and the reciprocal. So your new slope of your other line that would be perpendicular to this is going to be equal to -2 or -2/1. That's all you care. You don't care about the 9. It doesn't help. You're like, great. It's kind of like, and then guess what? One time I saw a green car. Nobody cares. Okay. So, they care so much. But the thing is, it doesn't help you get to your answer. And so I want you to say, hey, I want it perpendicular. We'll steal the slope and do the opposite reciprocal if you want to make it perpendicular. And so let's take the slope that we know we're going to use and with the point on the new line, and let's put them together to write the equation. And they say, put it in slope form. And so read the directions. if they say put it in point slope, you're going to do y minus the y coordinate of the point you know equals m, which is -2, and then x subtract the x coordinate of the point you know. If you add minus negative, make it plus a positive. And then this is a valid point slope formula. If they said leave it there, but they said don't leave it here, I want you to get it into slope intercept, which is y equals mx plus b. So distribute the -2 and solve for y. And you're going to get y is equal to -2x minus 18. So the truth is, if you graph this, you're going to see it starts at -18. You're going to go down 2 over 1. And if you plotted the point -7, -4, it would be on the line, as well as it's going to be perpendicular if you graph the other line. Okay, they would be at right angles to each other. Okay, which is awesome. Okay, you want it to be perpendicular to the other line, but go through this point. So they give you a point to use. They give you a hint about the slope that you're going to use for your new line, and then you go with it. So perpendicular lines have opposite reciprocal slopes. Well, what do parallel lines have? Well, parallel lines have equal slopes. And so if I want parallel to this line here, well, this line has a slope of -5. So parallel to it has to copy the same slope. So m is also going to be -5. And we're going to use this point here as x1, y1. So you just take those 2 points, x1 and y1, that point, the ordered 2 parts of the point, and the slope, okay, copy the slope, okay. Parallel lines have equal slopes, and perpendicular lines have opposite signs and reciprocals. And examples would be like 2/3 and -3/2. Those are opposite reciprocals. Okay, we did talk about the weird one yesterday where it's going to be 0 and undefined. Those are going to be perpendicular. They're not really opposite reciprocals unless you really bend it a little bit, but like 1/2 and -2 over 1, those would be opposite reciprocals or opposite signs and reciprocals of each other. So parallel lines have equal slopes. So let's write the equation. So y minus the y coordinate of the point you know is going to be -10 equals m, which is -5, x minus the x coordinate of the point that you know. Anytime you see minus negative, make it plus a positive. And we'll distribute because they want your final answer to be in slope-intercept form. So if I take -5 times x, I get -5x. -5 times 1 is -5. Excuse me, sorry. Here we go. And then y is equal to -5x minus 15. And that's going to be our answer. So that will go through the point that they gave us and be parallel to the line that they gave us as well. So it's all about clues. And so speaking of clues, they're going to say, are these 2 lines I gave you? And yesterday we talked about, are the lines going to be parallel, perpendicular, or neither? Neither is kind of an ambiguous, weirdy thing. So let's talk. I like how we are doing it today a little better. They say, are the lines parallel? Okay. And if we look above here, parallel lines have equal slopes. Okay. So if I say, hey, lines that do not intersect are going to be parallel. And the y-intercepts would be different, but the slopes are equal. Okay. Slopes are parallel. That doesn't make sense. When lines that do not intersect, those are called parallel. The slopes are equal. Okay, so that's what we should put. Slopes are equal if you have parallel lines. Okay, and so you know that if you've got parallel lines, your y-intercepts, of course, would be different, but your slopes would be equivalent. And so if you have perpendicular lines, okay, so that's parallel. If you have perpendicular lines, you know that not only do they intersect, but their slopes are opposite reciprocals, okay? And they're going to meet at 90 degrees. So anything that's not parallel will meet. The question is if they meet at a 90-degree angle rather than like an 80-degree or 70-degree or 20-degree angle. And then over here, we're going to talk about, do they just intersect as compared to being 90 degrees? Okay, so if the slopes are different from each other, like one is like 5, has a slope of 5, and the other one has a slope of 1/2, or one has a slope, like in our notes, we talked about a slope of being undefined, and then the other slope was like, say, 5/10 or something, 5/7 or something like that. So if the slopes are just different from each other, that means they're going to just intersect, okay? Intersect. If they're just different from each other. Now, if they're the exact same line, that means they coincide. So if you look at the equations, you're like, oh, they're both y equals 2x plus 3. Well, then they're going to, when you graph both of them, they're going to be the exact same line. So they coincide. So they could be parallel, where just the slopes are the same, but the y-intercepts are different. They could cross at 90-degree angles where the slopes are opposite reciprocals. They could just intersect because the slopes are different from each other. All lines that have different slopes will intersect to some way. And then the way that if you graph two lines in their exact same equations, you notice if you graph one, you're going to get a line and you're like, oh, let me graph another one. Oh, it's the same line. Well, they're going to be the exact same line. Okay, so if you graph y equals 2x plus 3 twice, all the points will be in common both times you graph it, no matter what color you graph them each in. And so if we look at these, okay, we can say, okay, are these two lines, if we would graph them, would they be parallel? Would they be perpendicular? Would they just cross them and just cross each other, intersect, or would they coincide and be the exact same line graphed twice? Well, and sometimes if you need to, you can actually graph it to look at it. These two here, notice they're not parallel, are they? They don't have the exact same slope. And so they're going to cross in some way. Will they cross at a 90-degree angle? The answer is no. Why? The slopes are not opposite reciprocals, okay? So they're not parallel. They are not the same equation, so they don't coincide. They're just going to intersect. The next one, the slope of the top equation is going to be negative 1/3, and you can't see the slope of the second one until you get it into slope-intercept form. So let's divide everybody by 6 to get the y equals mx plus b. You get y is equal to negative 1/3 x minus 2, or plus 2, sorry. 12 divided by 6 is positive 2. Notice when you get them both into, so this is intersect, okay, because they have non-equivalent slopes, so they're not parallel. They don't have opposite reciprocal slopes. They don't cross at 90 degrees. They just cross each other to some extent. And so this one both have a slope for negative 1/3. And notice they start in different spots. They're going to be parallel. Okay. One starts at 5 and goes down 1/3. The one starts at 2 and goes down 1/3. And so they're going to be parallel lines to each other. They will never intersect. So they're parallel. The last one, let's get it again into y equals mx plus b. So the top one already is kind of in y equals mx plus b. Y equals 2x plus 4 if you just kind of do this symmetric property. And then the next one, we're going to have to plus 4x. And we're going to get 2y is equal to 4x plus 8. And if you divide everybody by 2, you're going to get y is equal to 2x plus 4. Oh, wait a minute. They're not parallel. You'd think they might be parallel because they have the same slopes, okay? If the y-intercepts were going to be different, then they would be parallel. But notice they're the exact same line. And so they are going to coincide. If you graph one in red and the next one in green, they're going to be the same line and they're going to have a lot of points in common. So this would be coincide because when you look at them, they're the exact same line. And if you graph them twice, they will have infinitely many points in common between those two lines. Okay, so let's look at, we got 2 more concepts to look at, and this is a long video. It says, can you write an equation in slope-intercept form for the line described? Okay. And I think this is pretty much what we have talked about before. If you look at AB and you want to draw a line that's parallel to that, calculate the slope between A and B, and that would be m is equal to negative 2. Okay, so if you want to be parallel to AB, well, AB has a slope of negative 2. If you take the point 79, you can write the equation. Put this in point slope form, and you can write the equation. I will trust that you can practice that your own self. And then below here, it says, I want it perpendicular to WZ. Well, WZ, if you calculate the slope, you could count it. You're like, hey, it has a slope of 1/3. So this has 1/3, but if you want it to be perpendicular, you would have to use the opposite reciprocal slope. So you want the slope to be equal to negative 3. So if you pair that slope with this point, you could write the equation. So I'm going to trust that you can put that together there and just say, you know what, do you want it parallel to the line? Okay, cool, copy its slope. If you want to be perpendicular to the slope, well then take the slope and do the opposite reciprocal with it. Moving forward, we got one last step, and this says, okay, can you write the equation of a perpendicular bisector? And this is honestly, it's like 4 steps. And if you can follow step by step, you should be fine. This is something that we're going to put as extra credit on tests and quizzes. And so I want you guys to be prepared. -3,4 is the point that it should be. And this other one should be 5,2. I think you have that in your notes. I just don't think I fixed my note copy up here. And so it says, write the equation for a perpendicular bisector, okay, of a segment. And so I think the first thing is, if you have a segment AB, okay, and we can kind of almost look at this graphically because I think that makes more sense. Makes more sense. And so AB is -3,4. So if you go -3 and then go up 4, okay, if this is A, it's -3,4. That's A. And this second point is 5,2. That's over here. Okay. Well, a perpendicular bisector does exactly what it says. It bisects a segment in half and it's perpendicular to it. Okay, so if you're like, oh, I got to write the equation of this, great. Okay, well then can you imagine where that's going to be? It's going to chop it in half, okay, and it's going to be perpendicular to it. Okay, so that red line is what we're going to try to write the equation. And you could probably almost eyeball it and be like, I can figure this out myself, and I don't necessarily want you to, but it's true. So if you can, then awesome. But I think the big thing is like, okay, if it's going to be perpendicular, well, then we need to know its opposite reciprocal slope from the blue line. Okay. And then we also have got to know a point on the line. So once you know a point on the line and the slope, you're golden. Okay. And so, let's walk through this. So if you want to know this point that's halfway between here and here, you have to find the midpoint. And to do the midpoint, well, you're going to go halfway between the x's. You're going to take the x values. Here's the formula up here at the top. You take the two x values, so -3 and 5. Divide it by 2. That'll give you the x coordinate of the midpoint. And you take the y coordinates, which are going to be 4 and 2, and divide that by 2. And so if you take -3 plus 5, that's 2 over 2. That's 1. And then 2 plus 4 is 6. Divided by 2 is going to give us 3. So we're going to get the point for that midpoint, the one that's halfway between there, to be 1 and then 3. Okay, so that's going to be this point right here in the middle. That's going to be a point we're going to use, and we're going to plug in x1 and y1 into our formula. And we need the slope of that red line. And so to find the slope of the red line, we're going to start by finding the slope of our original segment, and we're going to take the 2 points they gave us on that original segment, and we're going to say, okay, y minus y over x minus x. So we're going to do 2 minus 4 over 5 minus the -3. So that's going to be subtracting these two x's. And you're going to get -2 over, it looks like 8. So your slope of the blue line is going to be -1/4. And it should make sense. Now we want to write the equation of a line that's going to be perpendicular and a bisector of it. So we found a point that's halfway between there. So a point on our red line is right here. We just need the slope of the red line. So the opposite reciprocal, the perpendicular line to our blue one, would be not -1/4, it would be +4/1. So if you take our midpoint, okay, that's a point in the red line, and you take our new slope, and notice it looks like that red line does look like it's up 4/1. Take those two values together, and let's write the equation in point slope formula. So y minus 3 equals 4, and then x minus 1. Distribute it out, and it says put it in slope intercept form, so you get 4x minus 4. And if you plus 3 to both sides, you're going to get y is equal to 4x minus 1. So let's see, does that make sense? It does if I had graphed the red line a little cuter, okay? So if I had done this line at -1, okay, let's graph it. If you go up 4, 2, 3, 4 over 1, this indeed would be perpendicular. Oopsie, I cannot draw on this thing today. Okay. It should be a perpendicular bisector of that blue line. Okay. My original graph was not very lovely. Okay. And so the better you do with graphing, the more likely you're going to say, hey, this actually makes sense. And so if you botch it, it should stand out. So if you tried this next one, I'll give you the answers and say, okay, well, how do you do this? You graph the points 3, 4. Okay, that's A. And you graph the point -1, 6. That's B. I'm like, okay, that's my original segment. I want to write the equation of the perpendicular bisector. And so you need the midpoint between here and here. So add up the two x's and divide by 2, add up the two y's and divide by 2. And so the midpoint between these is going to be 3 and -1 added together. And then 4 and 6 added together divided by 2. And that's going to be 1 and 5. And check it out. Does it look like that's the midpoint? Well, yeah, it does. Okay, so that's the point we're going to use for our new line. And it should be perpendicular to this segment. Okay, so it's going to be like this. So you find the slope between A and B. 6 minus 4 minus 5 over x minus x. You get 2 over -4. That's -1/2. The opposite reciprocal of that, to make it perpendicular to the original one, would be +2. Which makes sense. The slope of the blue line should be 2, okay, ish, and then we're going to take the point and the slope together, right? Y minus 5 equals 2, x minus 1. Distribute it out. 2x minus 2 equals y minus 5. Add 5 to both sides, and you get y is equal to 2x plus 3. And if you look at this, it should make sense. You start at 3, and you go up 2 over 1. You actually do get a graph that is believable to be the equation of the perpendicular bisector of your original segment. Thank you so much. Have a good day.